Hello and welcome to today's SCI webcast, Ask Us Anything, Generative AI Edition. My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make our webcast today as interactive as possible, so you can submit questions in the YouTube chat area now, and we will get to as many as we can. We did receive a number of questions prior to going live today, so again, we will get to as many as we can from the chat. For our first question today, we need to address what generative AI is and how it works. For this question, I'd like to go to Shing-hon Lau. Shing-hon is an AI security researcher here in the CERT division at the SCI. Shing-hon, welcome. Question one for you.
Well, thanks, Shane, and welcome everybody. So get us started off here. So what is generative AI? So maybe the best way to think about generative AI is to differentiate it from other types of AI. So the one that a lot of folks in the audience might be familiar with are various discriminative methods of AI. And the difference there is in discriminative AI, you're looking to tell the difference between two or more different classes of things. So a very classical example is in text, you're looking to see whether a piece of text is spam or not spam, right? Or you have a bunch of pictures and you'd like to know whether this is a picture of a cat or a dog, or a car, and so on. So what generative AI is trying to do is a little bit different. What it's trying to do is, instead of trying to tell the difference between different classes of things, it's actually trying to produce new elements from some underlying distribution, right? It's trying to generate something from some underlying data set. So the examples that folks in the audience are probably most familiar with are things like ChatGPT, right, where it's able to write paragraphs of text. There are also things like Stable Diffusion, which are designed to generate artwork of various types, and plenty of other methods that are out there that I'm sure we'll get to later. So the way all of these different techniques work at a very, very simple level is they ingest a lot of data and they try to understand what that data actually looks like. And then they try to generate something that looks similar to something that's already come before, right? Perhaps guided by some kind of prompt that the user has provided.
Thank you for that, Shing-hon. Now I'd like to introduce Rachel Dzombak. Rachel is an advisor to the executive director here in the SEI's AI division. And the question we have for Rachel is, what are the implications of generative AI for the Department of Defense workforce? Rachel, all yours.
Thanks so much, Shane. And like Shing-hon, very excited to be here today for this important conversation. The Department of Defense is the largest employer in the US, if not the world. And so what the potential for and the implications of generative AI are is to unleash that creativity and human potential across that really large scale workforce. We're already seeing with generative AI ways that it's increasing our productivity, making us faster. I don't know about you, but certainly I like when in my email it pops up suggested texts of "sounds good, thanks" to an email instead of me thinking of what that response has to be. Or if it puts out something that is confusing, I can quickly delete it and say, no, this is what I was actually trying to write. That small behavior of suggesting text is what we call augmentation. It helps us as humans do what we're trying to do just a little bit faster, or it sparks us to think about the actions that we're taking. And so I see the potential of generative AI for the Department of Defense workforce to be really significant. Over the past few years, we've heard a common refrain of that the DoD is not able to recruit as many people as the tech industry, or we're having to do more with less, or we don't have the skill sets to accomplish the tasks at hand. What if that could be changed? The benefits of generative AI, we're already seeing that people are playing with it as a just-in-time training tool. What if before your next meeting, you had all of the necessary notes scanned from what the organization has had a history of, and they're right at your fingertips? What if you had just-in-time training to do a new skill? What if you were a software engineer and you had a pair programmer? Well, we're already seeing that happen in a lot of workforces, including in the DoD. We're already taking advantage of some of that. So I see that the opportunity is for the DoD to kind of transform as a workforce and perhaps catalyze in a lot of the behaviors that people didn't previously think possible because we're a large organization or a bureaucratic organization. So lots of opportunity there.
Thank you for that, Rachel. Just scrolling through the chat, we have asked folks where they are attending from. And as always, we have a worldwide audience. I saw Peru, Brazil, Egypt, Canada, Colombia, numerous states in America. So we greatly appreciate everybody taking the time to spend the hour and a half with us today for this webcast. The next panelist I'd like to introduce is Jasmine Ratchford. And Jasmine is a machine learning research scientist, also in our AI division here at the SEI. And we had a question come in from Joanna asking, what are the most important factors an agency should consider before investing in infrastructure to support an LLM or large language model? Jasmine, all yours.
Thanks, Shane. So this is a great question. Large language models are one of the most prominent types of generative AI, and it's where I do a lot of my research here at SEI. And it's really important to think about what you're going to do with your large language model or any generative AI before you start buying infrastructure for it, because training a large language model and any type of generative AI can be really, really expensive. And besides just the normal concerns of, how many users do you have, what's the rate at which you're going to be, ingesting requests, you really have to think about other aspects of the inputs and outputs. For example, how large are those inputs going to be? Because the large language inputs, for example, for a large language model, the inputs can affect what type of large language model you can use and how downstream processes affect and contribute to the large language model ecosystem. So really thinking about, not just like the number of users, not just how many requests you're going to get per minute, but also, what are the size of those requests going to be? What other tools do you have at your disposal? So often with some of these generative AI techniques, you can augment them with other APIs, say a calculator if you need to do math, or some sort of additional database for retrieval augmented generation. So thinking about all of those tools that you're going to use with your large language model or any generative AI is going to be very helpful in understanding what infrastructure you want to use. And lastly, I just would also mention that you really want to think about who do you have on staff that can support that infrastructure long term? And that's really going to affect whether you want to look at on-prem resources or cloud.
Thank you, Jasmine. Now I'd like to introduce John Robert. John is a deputy director within our software solutions division, also here at the SEI. And we had a question coming from Ben that we're going to address to John. And what are the advantages generative AI brings in regard to traditional software engineering? John, all yours.
Sure. Thank you very much. And thank you for the question. There's actually a lot of exciting applications for generative AI in software engineering. It's a very interesting time in this area. So I'll start with some of the more common examples. I think many people have seen, how generative AI can create code. And it's actually can do that in a separate sort of chat GPT window. But there's also examples of LLMs and generative AI being integrated into tool sets like Copilot and Amazon Code Whisperer. But in either case, it certainly is very good and advantageous to create code and to write code. But it's also good at other things, modifying code, take this set of code and make these changes to it, and it'll create those updated versions. Generating tests and to run the code is another area of interest. Analyzing code, similar to like static analysis tools, but not limited to that. Look at this code and find these types of situations. But it's maybe most important to highlight two aspects. First, it's not limited to code level kinds of activities in the software engineering lifecycle. There are many things that software engineers do that are not specific to code. We're in meetings, we're looking at documents, we're trying to communicate with different stakeholders. But all these activities involved a lot of documentation. And so it turns out generative AI can be very helpful in those activities as well, extending into DoD and government software acquisition kind of activities and policies. And I think a second key thing is that humans are part of the process. They're not eliminated by these tools. The need for an engineer to spot, for example, where the code that's generated is inaccurate, or to make sure that the context is not lost. These are all human skills that are important and needed even as these tools provide major new capabilities.
Great, thank you, John. Just a reminder to the folks, the chat is open. Feel free to put in questions for our panel there. Again, as I said in the intro, we'll get to as many as we can, but feel free to start typing in some of those questions now. In the meantime, I'd like to introduce our next panelist. We have Doug Schmidt, and Doug is a professor of computer science at Vanderbilt University in Nashville, Tennessee. And Doug was also the former chief technology officer here at the SEI. So welcome, Doug. Thank you for joining us here today. The question I have for you is, how can generative AI be used now in the Department of Defense?
So riffing off of what John Robert just mentioned, there's a couple of different ways, actually 3 or 4 different ways that the DoD can use generative AI right now, and in fact is undoubtedly using it in many cases. One plays off of what John was talking about for software development. As most people know, that many of the DoD systems, especially the older systems, the legacy systems, are written in languages that are not as popular in the commercial world these days, like Ada or Jovial. And one of the great things you can do with a language model is you can train it to become fluent with whatever you train it on. So you could train it to become very fluent with understanding Jovial or understanding Ada and understanding architectures and designs and good patterns and practices of developing and testing code in those languages. So creating fine-tuned or custom LLMs that could help with the sustainment activities would be fantastic, especially for groups within the DoD that do organic sustainment of older systems where there just may not be as much workforce out there as there used to be who is fluent with these languages. So I think that's one area that would be ripe for the DoD to use right now with techniques that are available, and being able to team up with cloud providers like Azure from Microsoft and others that can provide distribution D and other types of government style access to the code bases. So that's one thing. Another area that is very fruitful is, as John mentioned, there's lots of stuff that goes on in large scale acquisition programs in the DoD that relates to working with large repositories full of documents. I work on a number of projects with the SEI where we have to look at regulatory documents, we have to look at specifications for safety and security and so on. And very few humans actually have global view of all the documents in these large repositories for big, large-scale acquisition programs. So the ability of LLMs to be able to analyze those repositories and make sense of them, to look for inconsistencies, to look for gaps, to be able to find a needle in a haystack, very valuable. LLMs are extremely good at analyzing and sifting through large amounts of text. And then the third and final thing I'll just say briefly, there's lots of support that can be provided now in operational activities with LLMs. And if you take a look around at some of the advertising and other collateral that's coming out from companies like Scale with their Donovan platform or Palantir with their AI platform, people are using these tools now for supporting operators and analysts who need to be able to fuse together large amounts of information and make sense and coordinate and contact with different other groups to queue other assets, to collect other intel based on signals and sensors that they are able to control. So I think those are all things that are happening right now, and I wouldn't be surprised if in the very near future we'd see a lot more of these types of platforms that are rolling out.
Appreciate that, Doug, and thanks again for joining us today. Last but not least on our panel, we have Matt Walsh. Matt is a senior data scientist in the CERT division, also here at the SEI. And the question for Matt, we've done a lot of talking, Matt, so far about large language models. We know generative AI is more than that. So what other types of content is GenAI producing? All yours, Matt.
Yeah, thanks for that question, Shane. And so, as Shing-hon alluded to in his opening remarks, another use for generative AI is to generate complex outputs. For example, you can use generative AI to create landscapes that, although they appear to be real or artificial, you can also use generative AI to create pictures of faces of people who don't really exist. And so this is an area of research here at the SEI, Deepfakes. A deepfake is a picture or video of a face that's been digitally altered using a deep neural network. So deep neural networks are computational architectures that are extremely expressive. They can create very complex outputs. And a picture of a face is among the most complex things that we can create. And so the flexibility inherent in deep neural networks makes them suitable for creating and manipulating pictures and videos of faces. No doubt in the conversation, we'll talk about some of the risks posed by deepfakes, but I want to start out by just talking about some of the beneficial uses of this technology. It's not inherently good or bad. So deepfakes are using deep neural networks to modify and create pictures and videos of faces can be used for editing and special effects, like in video games and in the entertainment industry. It can be used in education to take source content and translate it into different languages and present it to audiences using avatars or speakers who share the intended audience's characteristics. And deepfakes can be used for satire, humor, and in art and demonstration. So we hear a lot about deepfakes recently, and there are risks posed by them, but there are also legitimate uses of this form of generative AI.
Thank you, Matt. Appreciate that. We did get an audience question from Kirby asking, if you're hosting a general purpose productivity tool, how should you format the prompt? A classifier to classify user intent, then generate a prompt. So I'm going to toss that one to Shing-hon for some comments there. Shing-hon?
Sure. So I guess my response to this question is more that you should think about how to train users to do prompt engineering, right? So prompt engineering is the kind of discipline of generating the right prompt to get the question that you would like, or to get the response that you would like to your question. I mean, if you think about it, have you ever seen, your grandma use Google or something, right? And they want to find out something about the SEI, and what they type in is, hello, I would like to learn more about the Software Engineering Institute. It is located in Pittsburgh, Pennsylvania. Please and thank you. And you look at that and you laugh, right? Because, anybody who has a lot of experience with Google just types like SEI Pittsburgh info, right? And that's more than enough to give you what you want, and probably is more accurate in terms of the results as well. So if you are, thinking about using an LLM for a general productivity tool, one of the things that you're going to have to do is to train your users a little bit about what types of questions tend to be the most helpful, right? And how you can guide, and do very simple types of prompt engineering in order to get the results that you want, right? So if you were having somebody that was trying to generate code using a large language model, adding some text at the end to say, please generate secure code makes a big difference in the performance of that LLM and whether or not it actually gives you back secure code, right? Or if you would like a particular voice or tone out of the response, you can ask for particular types of formatting, and you can explicitly specify those, right? And these are all techniques that are relatively straightforward to learn, but they do require a little bit of, effort on the part of the user, and probably from the part of the, in the organization that's hosting this productivity tool to provide some guidance, right? Because this is still an area that is new to a lot of people. And so we're all like grandma in some ways as we interact with, large language models.
Okay, we had a question come in prior to the event from Martin asking, is there some institutions doing something about Gen AI regulations and ethics? So Rachel, I'm going to turn it over to you. I know our AI division is doing some work in that area.
Yeah, absolutely. I think that it's one of the big areas of research right now is, what does governance in the context of generative AI look like? We're looking at it in terms of taking two different perspectives, I would say. So the first is, how do you prevent issues, concerns, problematic use cases from happening in the first place? And a lot of that means that we have to understand the process that is being followed to develop systems and what's happening at each step, from the data gathering to data cleaning, et cetera, model development, you go on and on. And so I think the big thing there is to engage teams in asking speculative questions and taking that curiosity about, what happens if this is used in a high consequence setting? Or how could people misuse this tool in some way, shape, or form? I'd say nobody has the answers yet. It's just all doing work in the service of trying to prevent issues. At the same time, what we're also seeing is that there's an infinite amount of unmodeled phenomena in the world, and users are incredibly creative with how they interact with generative AI systems, how they act with the internet in general. And so there's no way that any team could prevent all of the issues that could potentially come from a system. And so I think the other big side of it is to be set up to respond to emergent issues. The root of the word responsible means able to respond. And so we're also seeing teams really be thoughtful about what it is to mitigate issues, knowing that they will come in one way, shape, or form. That said, I think right now similar to the last answer, we're in a phase of experimentation. And so I think people wish there were in place policies that everyone was following, and yet that's not necessarily possible given the emergent nature of the technology and the use cases that it's being used for today.
Thank you for that, Rachel. Next, we had a question come in from Elle, and we're going to ask Jasmine to address this one. What are the trade-offs between fine-tuning and prompt engineering for LLMs? Jasmine?
Right. So with fine-tuning, one takes the large language model and a bunch of data and continues to train the model, hopefully aligning that model more with the data that's provided or the instructions that are provided. In contrast with prompt engineering, the model stays stagnant and you are changing the prompts or you're changing the inputs in order to elicit a different type of response. And both can be used to improve the outputs. Fine-tuning is really helpful if you have particular instructions that you would like to learn, or if you would like to build models that are sensitive to very particular lexical or syntactic uses of language. So if your language use has changed a little bit, fine-tuning is really the way to go. However, fine-tuning doesn't really help with learning new knowledge. And in many cases, it's much easier to try to inject that knowledge at prompt time. So when you prompt the model, providing that with the additional context it needs in order to answer a question. So say you had a paragraph or a paper that you wanted to summarize, or you wanted to ask a question about, it's much easier to give that entire paper to the large language model, ask it to summarize that paper, rather than hoping to train it, fine-tune it on the large language, fine-tune it on the paper, and then asking that question. Another advantage of doing things at prompt time is that because the input contains the original text in many cases, you can actually get some sort of reference. So if you want to know, well, how did you know that the sky is blue? It can actually reference a piece of text in the original document, rather than just not understanding why it knows that information, which is going to be true if you do fine-tuning.
Thank you, Jasmine. We're going to move on to another question in the chat now from Shrinketh, asking how to evaluate risks when using code generated by GenAI products before deployment in a production, high-risk settings, and DoD use cases. Thoughts on traditional verification and validation methods or formal methods? And let's start with John on that one.
Sure. So that's a really interesting question, because I think many people are looking at leveraging these tools for those types of settings and environments. So first off, I would like to point out that this generative AI and applying those tool sets to software engineering lifecycle is part of a larger trend that the SEI mentioned in publication in fall of 2021 of AI augmented software engineering. So the first thing to think about is that there's a trend over the next decade at least about more tools like this coming to market and being available for people to develop software, test software, and deploy software. So under that umbrella, there's a variety of new challenges, right? And so first off, the code that is generated by these tools is known to have been trained on imperfect code. So that means that the code that's generated can also have artifacts of imperfection where things are not done correctly. There may be code defects, etc. There's actually research in this right now and a lot of interesting ideas out there. So I'll say first off, we have to acknowledge that the tool sets today, although improving rapidly, do have the capability to create inaccurate code and code defects. So that means that the software engineering lifecycle itself remains very important. That means doing the architecture, the design, the software development, the testing, the review. So humans and all those activities remain important. It's that these tools now provide ability to accelerate many of those activities in new ways. So, for example, in testing, creating new test cases, and in analysis of the code, looking through new aspects of where there could be problems in the code. So I think thinking about it as a way to accelerate the process as a whole, but not trying to leverage it just in generating code is a good start. And then I think finally, over time, you mentioned about formal methods. There are ways that I think architecturally, formal methods and other kinds of items will be integrated into tool sets more and more to leverage some of those strengths. They can still be leveraged today, but I think over time, we see those kinds of tools integrating more and more with AI augmented tool sets like LLMs.
Thank you for that, John. Doug, I know you do a lot of work in this area. Any comments to follow up from John on that one?
Yeah, just a couple things to amplify and extend of what John was talking about. Obviously, for decades now, we have been generating code from various higher level abstractions. This goes all the way back to things like Lex and Yak, for those of you who remember compiler construction when you were a student. We've been doing this with model-based tools. We've been doing this with domain-specific languages, and so on. So in all those cases, really the only thing that's changed is the AI is writing more of the code than used to be generated by these tools, which were written by people. But the same basic principles apply. You still have to have unit tests. You still have to have regression tests. You still have to have integration tests. So all the things we've come to know and love about trying to ensure the validity and verification and confidence in software are still there. Maybe one slight difference is some of those things, some of those artifacts may also be generated by AI tools. And then we have the question of who will check that the test cases themselves are correct. But I think not a whole lot has actually changed. The main thing that's changing is we're expecting the tools to do more work. The second point, just to quickly say what John was pointing out, I don't think we should expect AI to generate complete systems from scratch. We should look at this point about augmented intelligence working together with these tools. I do this all the time in my teaching, in my code development. I work hand in hand with the tool, and it doesn't write the whole thing. I write a lot of it, and it helps me out with some of the tasks that would otherwise be tedious and error-prone and boring for me to do. It helps complement, not replace, or supplement, not supplant. And one of the things I'll also just note real quickly, when you take a look at some of the people who've written skeptical articles about the benefits of using generative AI for programming, they almost always try one or two examples. The examples don't work the way they want. They don't spend time thinking about prompt engineering. They don't spend time thinking about how to use the tools properly, because there are different ways to use the tools, some which work, some which don't. Instead, they try a couple of examples, they don't get what they want, and they throw their hands up and say, see, the emperor has no clothes. And I think that's a real problem. We need to work on that. I call that tactic degenerative AI, where people overgeneralize from a few simple cases that didn't work without any additional thought and give up on the whole paradigm. That is certainly not the case for those of us who spend time actually playing with these tools day in and day out. They can work quite well when used properly.
Question from Hussam asking, how are security issues / concerns being handled with LLMs in production? Any tips for hardening against things like prompt injection? So we're going to go to our security person, Shing-hon. Comments from you.
Sure. So I think I have a very unsatisfying answer for this one, which is I don't think any of the security issues are being handled particularly well. And I think a lot of the reason for that is because the underlying technology and the understanding there of how to combat things like prompt engineering is there just aren't answers out there yet. And if you look at, just in the news, right, you look every few days, really, you see some new article about, how somebody managed to defeat the restrictions that were placed on things like ChatGPT, right? Or, the Bing chatbot, right? Or, Google's Bard, or any one of these big commercial systems that are being, developed and maintained by tech companies with, billions of dollars of resources that they're trying to pour into this technology. So that's maybe an indication that this is not a simple problem and requires sort of a lot to try to resolve it. What I would say is that, the actual technique that is often used here is to try to establish safeguards, right? It's to say, okay, we look at the incoming prompt and we figure out if this is going to violate, if the answer is going to violate some principle of the company that, of the owner of the technology, that they don't want to generate something. And then they'll also look at the response and see, the same thing, right? And that's why if you go to a commercial service and you ask it to, just generate, something like hate speech, it will say, no, I'm not going to do that. That's against effectively the terms of use, and you'll get nothing. Of course, it doesn't take very much effort to do some prompt engineering to get past those kinds of safeguards, right? So I think one thing to keep in mind is that, when we talk about prompt engineering and talk about prompt engineering and injection in a sense of bypassing some of these safeguards, it's important to understand what is the actual harm that is trying to be prevented, right? So for something like hate speech, the harm is relatively obvious, and we don't want to spread things societally. For other avenues, maybe sometimes it's less clear what a prompt injection is really, trying to, what kind of harm it's actually going to cause, right? And a lot of the types of prompt engineering and the differentiating between prompt engineering versus prompt injection, right, is often a relatively fine line, and it kind of depends on the user's intent, right? So if you have an ability to say, well, this LLM is only going to be accessed by trusted personnel, then you provide training and say, look, this is a tool, it can be used dangerously. However, it's important that, here's some training to basically stop you from doing that, and to help you understand why it's important that you don't use it for kind of, malicious purposes. For something that's more general, right, like just a fully public-facing chatbot, that's going to be a lot more difficult. And as you can see, a lot of the commercial entities are already struggling with that and trying to, prevent some of the harms that can be generated, both for their own sort of legal and kind of reputational sake, but also because there's a genuine interest to not generate a bunch of content and contribute to the negative sides of humanity.
Okay, we're going to bring Matt back in on for this question. We had a question come in prior to the event from Bart asking, in the battle against fake news, is there a way to detect if an image or video was generated by AI? Matt, we know you're doing work in this space.
Yeah, absolutely. This is an active area of research, not just here within the SCI, but throughout industry. And really, it's a game of cat and mouse. So in 2017, the first set of methods for generating very compelling deepfakes were released. And in the time that followed, a number of deepfake detectors were created. So it turns out if you take a picture of a face or a video, there are multiple layers of information that it contains. There is pixel level information, and you can do things like statistical analysis to detect anomalies at the pixel level. There's feature information, both spatial features and temporal features. So as you're looking at the image, pixel values that are adjacent to each other, or as you're watching a video, frame by frame features. Most contemporary deepfake detectors are trained to detect anomalies, both in those spatial and temporal features. When we're looking at a face, there's also a physiological layer of information. You can extract things like respiration and heart rate from the frames of the video. You can look at things like eye blinks. You can look at things like micro expressions. So deepfake methods aren't aware of all these physiological features. They aren't created in order to replicate all of those physiological features in high fidelity. And so the next generation of deepfake detectors, some that have very compelling results, focus on that physiological layer of information. However, it is a game of cat and mouse. So as deepfake detectors improve, our adversaries can refine methods for deepfake generation in order to defeat those detectors.
Thank you for that, Matt. We're going to move on to our next question in the chat from Carolyn. And we're going to point this one to Rachel. With regulations enacted by the European Union and proposed legislation from the US, how should AI companies respond regarding ethical, responsible, transparent, and trustworthy LLM development? Rachel?
Great question. Building on kind of the last question that related to ethics, I think the biggest piece is that companies start. I think as a lot of question marks are flying with the quick evolution of technology, it's very easy to put off, and we'll worry about the trustworthy or ethical part a little bit later. And it's critical to start doing that reflection. One of the best ways that one of the best strategies we use when working with teams is to first have them just reflect a little bit on, walk me through the last project you did or the last system that you were working on. What steps did you take? And we have people lay out their life cycle steps. And then we ask, well, which of those steps were technically compelled? And most of the time, the answer is about 20 to 30%. That 20 to 30% of the time, the steps were mandated by the technology or the infrastructure that one was using, or the data set, the use cases, et cetera. The other, call it 70, 80% of the decisions made, the lifecycle steps, were subjective. And in those subjective steps, that is where ethics intersects. That's where trustworthiness, transparency intersects. And a lot of the times, our teams are making decisions that are almost subconscious to them. Well, I do it this way because that's the way I've always done it. That's great, and it makes sense because that's how we as humans go through our workflows. But especially if we're seeing AI systems be used into higher consequence use cases, there's going to be additional scrutiny. And so that's step one, is just to reflect on your process and understand what are the places where you're bringing subjectivity to your lifecycle steps. The second is, because that opens up probably a lot, there's tons of rabbit holes that you and your team could go down, is to start to do some triage, to think about, okay, so what are the biggest sources of risk? What are the biggest places where we could see things go wrong? Let's start there. What are the riskiest assumptions we have embedded in our process, in the steps that we're taking? What are the biggest places where we could see a catastrophic failure or a significant impact to human lives? I think doing that triaging step and then picking one or two starting places is super important as a prioritization, because you can't, there's lots of tools out there that oftentimes have hundreds of questions that you could ask. And I don't know about you, but when I see a checklist with 200 questions, I feel overwhelmed. And so taking a step back and saying, okay, what are the first areas that we could focus on? That's a great starting place for your team. The last thing I'll say is there are lots of tools out there that you can peruse. So we at the SCI have published a lot of tools that can support teams trying to engage in responsible AI work. We co-authored with the Defense Innovation Unit a series of RAI guidelines and a set of worksheets that kind of guide you through ways of thinking, and ways that the goal of them is to spark conversation and engage in critical thinking as you go through different development steps. And the last piece is that you want to be thinking about, how do I envision what post-deployment looks like prior to the release? Thinking about, there was mention of guardrails, there was mention of test and evaluation. And I think so much of it comes back to doing that critical thinking. Who's going to be using this? For what? How could it go wrong? Building a culture in your organization to ask those sorts of questions, hugely important.
Great, thank you, Rachel. Let's bring Doug back in for a question. You kind of touched on this a little bit in your last comments, Doug. I know you're doing a lot of work with your students in this area, but how are you personally using GenAI in your day-to-day operations at Vanderbilt University?
We use it for education quite a bit. My philosophy has always been that the programmers of the future will work hand in hand with these tools, not replacing people, but augmenting them. And I feel it's very important that I help train my students to be effective at using these tools the right way, as opposed to the erroneous way. So we do a lot of work in the classes to leverage these tools wherever possible. I leverage it also in the research that I do. It comes in very handy for summarizing things in particular. I also use it quite a bit in my grading and assessment. I've built a static analysis tool using ChatGPT to analyze my student solutions to see whether they make frequently made mistakes in the code. I use it for other things, like taking the lecture videos I create and generating quiz questions that are fresh and up to date based on what we covered in class. I use it for almost everything that would have required me to spend a lot of time in the tedious and mundane aspects of teaching and education and code generation and writing assignments and so on. So it's very, very, very successful there. It's not perfect, but I find that with the right insights that I provide, since oftentimes I've created the material, I can tell when it starts to hallucinate. It actually is a productivity multiplier to the 100 or 1,000th degree. It's incredibly productive as long as you're careful in how you apply it.
Great advice. Thank you for that, Doug. Question in the chat from John Paulo asking, what do you think about a hybrid generative AI for generating code? Hybrid meaning LLM, neural, and MDD, symbolic AI. So let's go to John Robert for that one. John, any comments there?
Yes, first, absolutely a great question. My understanding is that's an area of active research, not just within the SEI, but also other places around the world. If folks have seen research in this. Love to see references to that in the comments below. But I think in general, I'll assume MDD is model-driven development. So let's back up and say, model-based software engineering has been around for a couple of decades now. A lot of interest in using models to generate code and using models to help reduce the cost of maintaining software, especially large sets of software over time. So the benefits have been proven, and it's an area of active, interest. But I think that there's also the idea that, ChatGPT and LLMs and generative AI, there's a lot of concerns, as we talked about earlier, about code being generated that's inaccurate or not correct. So hybrid approaches about trying to leverage not just the LLMs, but also leverage other techniques architecturally to address those shortcomings or those risks is really an active area of interest and research. There's many different areas under that topic. I think one of the things that we're going to see over time is how there's this back and forth, because there's also interest in how looking at a body of code that does not have a model, can generative AI help reverse engineer a model? And we've done some early experiments in that area and found, yes, it can. It can be fairly accurate in many cases. And so there's a lot of area there, because much of the software that's out around does not have a good model. I think people have experienced that. They don't have good documentation because it diverges from the actual software. They may not have a good model, and so that's been one of the challenges in model-based engineering. So bottom line, it's an area of interest. Architectural approaches that bring together these different techniques to minimize the risk of generative AI for code generation will absolutely be an area of active work, and we believe that there's a lot of opportunity there.
Great, thank you for that, John. We had a question come in previous to the event, and this one's for Shing-hon. Alicia had asked, how might generative AI capabilities be misused and abused, and what types of harms might that cause? Shing-hon?
Sure. So that is there's a lot to address there, right? So probably the thing that immediately comes to mind are things like disinformation, right? So we have seen, in kind of US politics and really throughout the world, right, this idea of, fake news, right, of disinformation in general becoming a bigger and bigger part of our kind of popular culture, right, and the environment that we live in. So generative AI is something that is very capable of generating, news stories or potentially even evidence or various other things that might help contribute to that mis or disinformation. And especially, one of the properties of generative AI is that it tends to hallucinate a lot, right? And so if you read subsequent outputs from the exact same large language model, for example, they may not necessarily agree with each other, which is usually a problem, but that is very much something that is a feature and not a bug when you're trying to create mis or disinformation, right? You will create a lot of confusion by having a lot of stories that kind of disagree with each other. There are also some areas that, we've already seen that various kind of malicious intended actors are trying to use things like generative AI in order to actually perpetrate their various misdeeds, right? So for example, there's something called fraud GPT and worm GPT, right? And these are kind of obviously meant to emulate the naming convention of ChatGPT, but these are kind of paid, dark web kind of services to generate things like malware or to generate things like phishing emails, right? Or whatever is needed in order to perpetuate fraud, right? So these are opportunities for kind of malicious actors in order to be able to very effectively do their jobs, right? And to pursue their interests, right? Which is usually trying to profit in some way. And that creates a little bit of a difficulty because, in traditional cybersecurity, we think of it as, the defender basically needs to win 100% of the time, right? If you have one data breach, that's all anybody really cares about. If you have one, scam that's successful, that's what everybody cares about. You don't get credit in a way for the 99.9% that you deal with successfully. And so when you have an adversary who has access to something, like one of these malicious intended LLMs with some of the safeguards removed, or perhaps even with some fine tuning done to create ever more potent, malware or phishing emails, then that becomes a problem for your defender, because now you have a much larger quantity of threat. And it's a quantity of threat that you may not actually be able to handle. And that quantity of threat is also maybe more sophisticated than what you've traditionally seen, right? That one of the things that GPT, for example, or large language models, I should say, not GPT, are very good at is writing very compelling and seemingly, grammatically correct and well-formatted pieces of text. And that's something that is a cue that a defender will use to say, well, if the English of the text that I'm reading is really broken, is really confused, maybe that's an indicator that this is something that's malicious or phishing, right? But if you see something that seems perfectly well written, seems like it could have come from your chief financial officer, for example, you're much more likely to take that very seriously, and that might make you more likely to fall victim to fraud.
Thank you for Shing-hon for that one. Matt, you're also doing work in this area. Anything to add to that?
Yeah, sure. I'd like to elaborate on part of Shing-hon's response about the threat posed by deepfakes. Fairly recently, Senate Mark Warner, the Senate Intelligence Committee, made this remark: with the presidential year coming, deepfakes and manipulation could take place. Watch out. And I mean, that kind of perfectly captures a national level concern regarding deepfakes. We've seen deepfakes attacks at all levels, at the local level in bullying incidents, at the state and national level with defrauding consumers and businesses, and at the international level with military disinformation. I'm sure most of you saw a few years ago the false video of President Zelensky that surfaced. And that really is just the tip of the iceberg. So in terms of weaponizing deepfakes, there's two kind of general classes of approaches that we see. The first is to create an image of a person who doesn't exist in order to make a richer persona, and then create, for example, a social media profile for that persona and use it to amplify disinformation and misinformation. And then the other approach is a more targeted one, where the adversary takes video of a known public figure and then manipulates the video to kind of pose the person saying or doing something that they had never done before. So it's kind of different attack vectors used with deepfakes. The other thing that I wanted to point out is that generative AI, deepfakes don't exist in isolation, but other forms of generative AI can be used to amplify the effectiveness of deepfakes. So it's possible to take a large language model and use it to create a transcript that mimics the speech patterns and the linguistics patterns of a political figure in order to create a highly compelling transcript. And then it's possible to take a synthetic audio generator to create a voiceover that nearly perfectly mimics that individual. And then lastly, the deepfake can be layered on top of that to create the video to go along. So these different forms of generative AI don't exist in isolation, but the emergence and breakthroughs in all of these areas can be combined for a multiplicative effect in order to create a very compelling fake.
Great. We're going to bring in John Robert for this one. Hank had sent in a question prior to the event where he said, I've observed a concerning trend. It appears that traditional software engineering profession is gradually diminishing, and this realization does worry me. I'm curious to hear your thoughts on the growing concerns surrounding the increasing potential dangers posed by AI. John, any comments to that?
Yes, I think there's a lot of people that have been concerned. There's a lot of stuff even in the media about, the age of the programmer is ending, ? So a lot of those things are just really overblown. I mean, humans are part of the software development process because of important reasons, not just because LLMs are imperfect. Software development activities involved a lot of context of understanding, requirements, understanding architecture, understanding how to deploy. So LLMs are certainly able to accelerate and augment people in all these activities. But there's a number of risks. We've talked about some of them here, but in over-reliance on LLMs, especially for mission-critical or safety-critical software, has a lot of problems. And I think there's been stuff in the media too about how other professions may have relied too much at times on the LLM output, and it turned out to generate erroneous output and got folks in trouble. So, but the point is that this is just one of numerous advancements in software engineering. where the skill sets of engineers and people are even more important. There's been time in the past with different revolutions where people also felt software development and engineers were going to be less relevant. It turned out to be more relevant. So let's talk about it specific. So prompt engineering is an area of high interest because it's very effective at getting the most out of the models. Doug talked about trying to use these tools the right way. And so it's kind of the, if people use it the wrong way, it's the garbage in, garbage out kind of thing. It can generate a lot of inaccurate stuff. But if we have trained individuals that understand the context, that understand software development, it allows them to use these tools very effectively and maybe walk, the LLMs with a series of prompts to create a very specific and very effective set of outputs that are then used in the software development activity. So it will certainly also mean that engineers that are able to use these tools and are really comfortable with these tools and are able to effectively integrate them into their software processes will be in higher demand or higher use. So I think the risk is really about training, as Doug was talking about training, the future computer scientists and software engineers. It's really about getting more and more people comfortable with the technology, understanding the limitations, and then trying to advance and move forward, understanding those concerns.
Okay, we're going to go back to the chat, a coding question. So we're going to point this one to Doug. Kavitha had asked, how hard/difficult is it to detect if the code generated by AI was versus human? If an organization is trying to avoid copyright violations from using code generated by AI, what should be done? Doug?
I think you can imagine as a computer science professor, we worry a lot about this in our classes because we're worried that our students will stop thinking for themselves, as per what John Robert just said, and start just generating everything from ChatGPT or Claude or whatever. I think more broadly as an academic, a lot of other disciplines that rely on writing and essays as a way to assess are also very worried because it's hard to tell the differences. So real quickly, we had a tool last semester in the spring when things were very new that purported to be able to identify automatically generated ChatGPT style answers to essays. And we stopped using it because it was so inaccurate. And I think the same thing is going to be problematic with code, especially as these tools get more sophisticated. But real quickly, here are a couple of things you might think about. Oftentimes, LLMs today, may not be the case tomorrow, tend to generate relatively uniform code snippets. They're relatively straightforward oftentimes. Oftentimes also, ironically, if you ask them nicely, they will generate lots of comments and documentation. A lot of programmers I know don't tend to do much of that. So that would be one way you could tell. If it's nicely formatted and carefully constructed and commented, it might be written by a machine. But if you really want to be able to, so first of all, I don't think we're going to be able to tell very quickly as these tools get better. It's just not going to be possible. If you're worried about copyright issues, then a couple things you might think about in terms of detection might be using some kind of stylometry analyzer, which you could probably create with an LLM, where you would know your programmer's style. And if all of a sudden their code stops looking like what they typically write, you might flag that potentially as being something that they got from other sources. The tricky part there is being able to differentiate between an LLM versus something you would get from, say, Stack Overflow, which a lot of other people use in many ways to help simplify the code process. You could also imagine developing machine learning classifiers to try to detect these things, but I think it's ultimately a losing battle. So if you're really concerned about it, you probably want to go back to code reviews. You want to make sure that people are able to show the provenance of what they produce and be able to justify and explain what they do. And that's essentially what we're doing in our classes. What we're doing is we're allowing people to use these tools, at least some of us like me and some of my colleagues, but we make sure that they attribute where they got the code from or whether it was generated by the ChatGPT or Stack Overflow or from their brains and fingers. I think that's about the best we're going to be able to do. I think it's a fool's errand to expect we're going to be able to detect this stuff with any degree of accuracy in the very near future, sadly.
The next question in our chat, we're going to go to Jasmine for this one, from Brian asking, AI is changing so much. Any comments whether to try company-wide AI initiatives now or just try to narrow use cases? And if you go with ChatGPT, for example, how hard is it to change to another model? Jasmine?
Right, that's a really good question. I think that's something that we've struggled here with, trying to incorporate the latest and greatest large language model into our research when those latest and greatest models are changing, on a weekly basis. So luckily, the open source community has built a lot of tools that help researchers like us incorporate new models. So for example, we've used things like LangChain or other tools that other systems that will allow you to basically put in any model as the large language model in the ecosystem that you're trying to create. So we're trying to create a web app that compares two models. Well, we need some way to switch out those models really quickly, and those tools do exist. And so from the technical perspective of just taking a model and switching it out with another model, as long as those models aren't too different, I think that is possible. And really, a lot of the different models that are coming out nowadays are based off of one or two, three or four, I should say, foundational models. So they generally have the same structures. I think that there are some other technical challenges in swapping out models, but I think this is something that is possible. More thinking a little bit further down the line, I also think that some of the prompts that, say, you create for one model should be generally transferable to another model. So if you create a prompt template for a llama model and then you want to use it on a GPT model, I think that's something that is easily transferable. So whether you want to do this to your entire company and do it company-wide, or continue to just use it with a small number of users, is really dependent on your use case and how you're using it and how technically savvy your users are. But generally, I think that the constant churn would probably be too much for an entire company.
Rachel, how about you? Anything to add from an organizational perspective there?
Yeah, definitely. This is not unique to generative AI, but the biggest barriers to any technology adoption effort tend not to be the technology. The obstacles are culture, a risk-averse culture, or an inability to do experimentation, to do organizational learning as a company. And so I think that that's the place where Jasmine just so eloquently laid out the technical considerations from an organizational perspective, starting with a narrow use case, just to show what's possible and to be able to generate a set of stories is really important. We as humans, we receive new information with our fists up. We're always scared of change. It's related to our biology. We can't necessarily change that. And so what helps us to spread technology across an organization is to be able to tell stories and show, hey, look what's possible. Look what I was able to do. Doug has talked about his efforts in education. I'm sure he can go to his fellow computer science professors and tell them stories. Here's how the students responded, which might gauge their interest a little bit better than if he just said, hey, we as Vanderbilt University are going to roll this policy out. And so starting with a narrow use case, it helps you and your team figure out what are the obstacles and the design considerations you need to think about. And it helps you generate buy-in over time, because you're able to say, hey, if we were able to do this on this one narrow use case, well, what do you think would be possible if we did for this broader use case? That's what can help get internal investment into your ideas over time.
Thank you, Rachel. Let's go back to another chat question on prompt engineering. So we're going to start with Doug on this one from Hussam asking, what are your thoughts on the current and future state of prompt engineering? Will certain popular techniques, reflection, multi-shot prompting, summarization still be relevant? Doug?
Yeah, that's a great question. I think the first thing to remember is that prompt engineering is essentially natural language programming. And it's already the case, and it will certainly be the case in the future, that pretty much everybody who interacts with an LLM will be a programmer. They won't be a programmer in Java or JavaScript or C++ and so on. They'll be programming the LLM to do their bidding. And the main difference, of course, between programming with natural language and programming with more structured languages is there's a lot more room for ambiguity. And so I think we're always going to have to be aware of some form of prompt engineering, even as these tools get better at trying to ferret out our intent, because English language is fundamentally ambiguous. You can mean different things the way you phrase stuff. And also, to what Jasmine and Rachel have been saying, they're different tools. So if you ask a question to ChatGPT 3.5, you ask a question to ChatGPT 4, you ask a question to Claude or Bard, you're going to get different responses often. Now, here's the other thing that's important. People right now think that prompt engineering is just about how you interact and ask questions and make requests to an LLM. But if we start taking a step back and think about the engineering part, we quickly realize that there's engineering dimensions in software engineering that are going to be just as important for prompt engineering. Version control, testing, release to release compatibility. And especially as we start trying to use these technologies to build things that we expect to last and be sustained at the level of prompt engineering, we're going to have to be a lot more concerned with these other engineering dimensions. So it's not just about the way you phrase things to the LLM, it's about the way you do all the other stuff that we take for granted in the software engineering development lifecycle. And that's something we've only begun to scratch the surface of, and I think something that the SEI is particularly well equipped to explore because we have a lot of expertise in software engineering.
Jasmine, obviously you're doing a lot of work in this space as well. Anything to add to Doug's comments?
Well, I think Doug said it really, really well, that, you know, this is engineering in natural language. That's a really great way of saying it. One thing I did want to add to this is also just highlighting that a lot of large language model applications actually use a lot of different tools. So they'll have a calculator, they'll have an interface to, you know, Mathematica or something else. And so one place where I do see that prompt engineering might grow is how do we do better prompt engineering with these APIs so that we get the right inputs into those APIs. And I'd be kind of interested if there's a little bit of back and forth between how those APIs are going to be eventually constructed, understanding that a lot of the inputs are coming from these large language model systems. So it would be interesting to know, you know, is the entire ecosystem going to change? But definitely the prompt engineering, you know, the prompts for those types of APIs is going to change. It's going to be very influential to how large language model based applications use those tools.
Thank you for that, Jasmine. I want to go back to a question that we had submitted prior to the event. So I wanted to bring in Shing-hon. Lawrence had asked, how do we test how well generative AI capabilities are performing? Shing-hon, comments to that?
Sure. So that's a question near and dear to my heart because that's where a lot of my work resides. So a lot of the answer to that question is really you need to know what you're actually aiming for, right? So it's the same as any other test and evaluation question. It's like you need to actually be able to define what success is, and you need to be able to have that, you know, not only at saying like at the model level of, hey, my model outputs something that I find, you know, has a good enough, you know, blue score, rouge score, whatever, n-gram score, or whatever kind of model level metric that I'm looking at. But you also want to talk about, you know, how well is sort of the entire system performing, right? And that system might include all of the data that you're actually ingesting, right? Where are your text sources? How are you updating your text sources? How do you make sure that the inputs to your text sources aren't the outputs of other generative AI that's, you know, that you're you know, accidentally trawling the web and grabbing, right? These are things that, you know, we know have potentially huge consequences for how well a system is going to perform moving forward, right? If you're using safeguards, if you're using guardrails, right? How do you check whether or not those are actually performing well? And what does it mean for you as kind of the owner of the system and for the users of your system? How do you know whether or not that's actually appropriate? Right. And then finally, to ask the question, well, whatever mission it is that I'm trying to accomplish, right? And it could be a DoD mission in kind of a very traditional sense, or, you know, if you're trying to use a large language model in order to, you know, entertain an audience by creating poems or songs, right? Then entertainment is your ultimate mission. Understanding what those metrics are there and, you know, what you actually care about achieving. And on the flip side, right, to go back to some of the harms that we were talking about, to understand what would be an unacceptable outcome, right, where you would feel like the system not only didn't give you quite what you wanted, but actually maybe created something that was actively detrimental for, you know, what you're actually aiming for, right? So it's a very broad answer, right? There's no one set way to say, well, this is how well this generative system is actually doing. It's really trying to understand, well, what is it that you're actually trying to get out of it? right? And once you understand what you're trying to get out of it, trying to boil that down into specific metrics and measurables that you can actually look at. And, ultimately, I would say at the end of the day, what you're trying to do is to say, this makes life better in some way for the end user, right? Whether it's as simple as entertainment, or it's something that's a DoD mission, right? You're talking about here, what's the time to response, right? What's the accuracy of some particular DoD mission, and things that kind of very serious at that level. Being able to quantify those and to articulate those is really crucial to understanding whether or not this generative AI system is doing what you want.
Thank you for that, Shing-hon. Next, we'll go back to the chat. I wanted to bring in John for this question from Carolyn, asking, how can the software industry educate users and the general public to better understand the appropriate versus inappropriate use of LLMs? John?
Another really interesting question. So I was at a sponsored event by the National Science Foundation back in June, and we had various different speakers. I think Doug was one of the speakers at that event, as well as others, including academic researchers from around the country, people from government, and some from industry. And this question came up: how do we educate the public more about the use of this technology? So I don't have a full answer, but I can share some of the thoughts, which will also be shared in an upcoming blog, I think, that the SEI will have shortly, as well as a joint report coming out on a summary from that workshop. But one of the things that came up is clearly articulating and awareness campaigns kind of thing, where what are LLMs good at? What are generative AI tools good at doing? For example, they're good at summarizing large sets of information, like you've heard today. They can be very good at finding inaccuracies across information. Look at these two things. It could be document and code, or two documents, and find out where there's some inconsistencies. It can be very good at that. But it's also understanding where these tools are not very good, maybe, or we are leaning too much on them if we depend too quickly upon them. For example, some of the risks we talked about with generating code, especially for mission critical applications. So informing on where these technologies are strong and where they're weak, knowing that they're going to improve over time, is one of them. I will also share that another interesting point from that conversation was the need for more transparency in the data that's used to train some of these models. I think to build more confidence in understanding, how these models can be, where they'll be stronger or weaker in certain types of questions, is understanding better and documenting better what kind of data sets they're trained on, and understanding, more detail how that's being done. So I think all those elements are going to come into shaping more about training, and I'm sure there's more to come, but it's a fast moving area, of course.
Rachel, anything to add on that?
Yes, the other piece I wanted to add is really an opportunity to reframe that question. Because yes, the software engineering industry can educate users, but how can users educate the software engineering industry? With any new technology, it's always an opportunity to see what are the creative ways that people are using this, both for good or for bad. Because all of the adversarial examples that we've talked about here today, we can learn from those, and that can improve our understanding of what safeguards we need to have in place, or how do we have limits. And so I think making sure, it's the human-centered designer in me needs to have my eyes open to how are users engaging with this technology in ways we didn't anticipate or didn't expect. I think there's so much learning to be done there versus the developers trying to prescribe exactly how it could and would be used. And I think it's not to disagree with anything John said. I think all of that is of training on what the technology is so important for democratization and access to technology, and for improvements over time. It's really important to think about the extreme uses and creative uses that no one could have anticipated.
Thank you for that, Rachel. We'll move on to our next question in the chat from Shiwei, asking, let me find it. I lost it. There we go. Any real differences between mathematical statistics and AI? Let's go to Matt Walsh for that one. Matt?
Yeah, sure. I think it's useful to take a step back and kind of establish the landscape of AI and its various subfields. So at a high level, AI involves computers behaving intelligently. And there are a variety of ways that you can get computers to do that. One way is to provide the computer with pre-programmed knowledge. And in fact, this was the spark behind the first wave of AI, creating computers that performed intelligently, but in pre-programmed ways. This is sometimes called automation now. As humans, we behave intelligently, and one of the ways that we do that is by learning through experience, by learning through our interactions with the world and with one another. So one way that we can get computers to behave intelligently is through learning, and this is where statistics and machine learning comes into play. This approach was the spark behind the second wave of AI. The second wave of AI concerned computers using statistical learning rather than pre-programmed rules to infer how to perform tasks. In particular, when you look at systems neuroscience and the human's neural architecture, in particular the way that the brain is arranged, there are layers of neurons, and the connection weights between these neurons change through experience, and that's the neural basis of learning. So most recently in machine learning, the human neural architecture has served kind of as a model system for how you can create a computer to learn. And this is called deep learning. So the third wave of AI concerns deep learning. It makes use of increasingly expressive models that are capable of achieving superhuman performance on a wide range of tasks. So to kind of go back to the original question, AI generally concerns computers behaving intelligently. One way to get computers to do that is through statistical and machine learning. So that's a sphere within AI. And then kind of even more narrowly within that ML sphere is deep learning, a particular approach to learning.
Thank you for that, Matt. Question specifically to Doug from Ben in the chat asking, don't BDD frameworks, for instance, Cucumber, look like the future of software engineering? Any comments there, Doug?
First, acronym soup, BDD. I'm not sure what that means in this context, unfortunately. So we'll have to get some clarification there before I can answer that question.
Okay. Let's go to our next question here. We got one from Laura that came in prior to the event. I think this one is for Rachel. Is the SEI doing any work to create a project lifecycle model for generative AI or LLM projects, or can you recommend one? Anything there, Rachel?
Yeah, we certainly are trying to understand the project lifecycle in the context of large language models, I would say. It's under the broader umbrella of our initiative we have going on AI engineering, which is really about how do you do AI as well as it could be done, from a human-centered perspective, a robustness perspective, as well as a scalability perspective. So we have a couple of projects going on right now, leveraging large language models for mission outcomes. And part of our work there is to extract lessons learned as well as to reflect on our own process and say, how do we do this better? How could we bring a more robust engineering process to the projects that we're working on? We have some released on that front, but I think more is to come, especially just because of how emergent the space is right now with large language models and generative AI.
Okay, thank you for that. Doug, just to follow up, if it helped, BDD, there's people in the chat are saying it's behavior-driven development.
Yeah, I think that's probably similar to what we were talking about a few minutes ago about how prompt engineering is essentially natural language programming. And it's my understanding that Cucumber and other tools like that are trying to raise the level of abstraction so that subject matter experts or systems engineers or non-software developers can contribute more fully and fulsomely with the activities in the software lifecycle. I think, as I was mentioning before, more and more people will be programmers with this approach, but I think there's also going to be an enormously important role for those of us who still program the old-fashioned way by using third and fourth generation languages, because there's an awful lot of stuff, especially in safety critical and mission critical real-time and embedded systems, where you don't want to rely on the higher level abstractions. You really want to have very fine-grained control over the various parts of the system. So I think the great thing about BDD and prompt engineering is it'll allow a wider spectrum of stakeholders to be more fully engaged in the software and system lifecycle, which is very important. and people may be able to be more engaged at understanding what's going on. It may make it easier for the customers, for example, and the people who are sponsoring the work to get a better sense of what's actually happening without themselves having to become subject matter experts. And this is something that's actually very near and dear to my heart. For decades, when people in other disciplines would come to computer scientists and say, I'm a chemist, I'm a biologist, I want to use computation in my work, what we would tell them is, great, we'll teach you JavaScript, we'll teach you Python, we'll teach you Java, which really isn't the right way to go about addressing their needs. It's really about having them be facile with computation, and tools like LLMs and BDDs will make that more feasible, but it doesn't mean that they're replacing developers. It means that people are able to be more effective in their domains without having to become a programmer in the classic sense, but they're still programming, and therefore the things that we talked about before about prompt engineering and versioning and testing and maintenance become even more important, because people without those areas of expertise are now building artifacts that are expected to last over time. And we all know that causes consternation if you have to deal with the bow wave of sustainment and maintenance over time.
Thank you for that, Doug. We got about 10 minutes left, so we're caught up in the chat online. I have one more question that was submitted previously, and I think I'm going to turn that one to John. But before we do that, I will go to each panelist just to give you a heads up for maybe just a closing thought or current work that you're doing, anything you want to highlight before we wrap up the event. But the last question we have currently is, I'm going to go to John, is came in prior to the event from Aaron asking, is it possible to align open source LLMs to unfamiliar proprietary programming language that the model has never seen before? John, any comments there, or anybody else?
I can start, but I welcome other comments from other panelists here, because I think there's a lot of perspectives on that one. I think we've been really surprised, at least a lot of people have been surprised about how extensible LLMs are. They're certainly better at their data sets they're trained in, but they can be extended in different areas. So I think some of the topics that have been discussed about trying to fine tune models, and is certainly an area for open source models that can be done, finding new data sets to create that fine tuning, and then also finding ways that, to play to the strengths of the data that it has been tuned or has been trained on, and using prompt engineering to get the most it can out of that information, and then try to translate it over to an area of new application. So I think there's a variety of techniques, but I will also caution, one of the things that we've been seeing is that there's a lot of opportunity with these tools to do things differently, and that may or may not mean that it's better, right? So we have to always keep in mind that tools are just that. They're helpful for some things and not helpful for others. So if we keep in mind that there's maybe cases where these tools may just not be as effective as it needs to be, is also an important area that we need to acknowledge and sort of say no, maybe in the future, but not now.
Thank you for that, John. Shing-hon, anything to follow up on that? And as well, your closing statement or anything you'd like to highlight, work you're doing, Shing-hon, anything you'd like to close up with for your closing thoughts. So we'll pass it over to you.
Sure, sounds good. So maybe the answer to the question here is also really kind of good closing thought, I think, right? So the crux of the question here is, while it's posed in terms of coding in an unfamiliar programming language, the question is, well, how do you get an LLM to have domain expertise, right? And that domain expertise could be in a particular coding language, or it could be in an area that is relatively unfamiliar and where data may not necessarily be present in kind of the large language model, the foundational large language models that exist out there already, right? So for the DoD, that's things like, intelligence, right? Where obviously you're hoping that's not just out on the internet sitting somewhere, or if you're running a company, right? This might be the proprietary secrets of the company that you would like to be able to access internal to the company, but which you would really prefer not to be out there in the world. And so there are kind of two major ways that LLMs can tackle this. One is you try to just offer it some small set of documents and say, try to operate in the context of these documents and just use all of the knowledge that you have from, all the gigabytes and terabytes of data of, English text that you've processed. And another is to offer fine tuning, right? To say, here is a trove of documents that are of the particular domain that are, particularly relevant, right? It could be some, some DoD mission space. It could be some very niche area of law or of science, right? And the more information that you're able to provide, the more likely it is that the LLM is going to do well and to really help give the output that you want, right? Ultimately, what an LLM is doing is it's saying every time it wants to generate a new token, which basically is a new word, right? It looks and says, well, what's in my training set, right? Has everybody else tried to say after the words that I've said before, and I'll try to pick one that seems the most reasonable and the most likely. And so if you are able to show that LLM lots of documents that really clearly articulate certain principles that are specific to that domain of interest, then it's probably going to do pretty well. Otherwise, it will just do its best and it might hallucinate something that could be totally wrong, right? So there really is it's still an area of active study, right? How to best fine tune or to provide context for an LLM to get it to have that domain expertise, because it's obviously highly relevant when you're trying to do something more interesting than just kind of a ChatGPT style, open, chatbot. But that's something that the best techniques are still, to be determined.
Jasmine, any closing thoughts from you? Anything you'd like to highlight?
Yeah, I mean, I think, this is really exciting for me to hear everyone else talk about these issues as well. These are things that the group I'm working with at SCI is working on, understanding, how to build that domain expertise for specific DoD customers into large language models. We've looked at a variety of different techniques, including fine tuning and prompt engineering, and there are definitely advantages and disadvantages to both of those. One other thing that we haven't done as much research on quite yet, but we're really starting to look at is things like chain of thought reasoning that you can do with large language models, which may help it which may help prevent it from hallucinating as much and make sure that there's some sort of traceability in terms of the information that it's providing at the end of that output. One of the things that I've really learned about large language models is to really think about it as an ecosystem, not just like a singular model. It's really about the model, but also the prompts and all of the tools and how you use it and how you iterate over it, and all of the data that goes that's used. In the future, I think that we're going to see more well-curated data sets to allow us to improve how large language models can be used for certain domains. So I think I'll leave with that. I'm really looking forward to seeing these smaller large language models that are trained on curated data sets and think about things like chain of thought reasoning.
Great, thank you. Matt, final words.
Yeah, sure. So with generative AI, as with any new technology, there are risks of disuse, abuse, and misuse. And kind of starting with misuse, so this is using the technology in the intended way, but in doing so, inadvertently causing harms. And so with using an LLM, you could query it for a piece of information and it could return something that's factually inaccurate and the user could accept that. That would be an example of misuse. Abuse is taking the technology and using it intentionally to cause harm. So a threat actor could use an LLM to create new types of malware or to create social engineering attacks. The risks of misuse and abuse are real, but the third category there is the risk of disuse. So foregoing the potential benefits of the new technology for fear of adopting it. And I just appreciate in today's conversation having heard about steps that organizations can take to deliberately reduce the likelihood of misuse and abuse in order to create that net positive for adopting the new technology.
Great, thank you for that, Matt. Rachel, how about from you? Anything you'd like to highlight or close out with?
Yes, from my perspective, innovation is a learning process. And when any new technology comes to bear, we have, as organizations, have an opportunity to learn. We learn through experimentation. And so for anybody who's leading a team, who's a manager, who's leading an organization, it's a great reflection to say, what experiments are we running? And more importantly, what are we capturing from those? What how is that improving our team's technical abilities, our stakeholder, how is it addressing stakeholder needs, et cetera? I think that especially right now when there's no, I mean, we covered this on the panel here today, that there's no one right answer. There's a multitude of approaches, the research space, the technology, all of it's evolving every single day, which means there's a lot of room to play and experiment and see how you can engage with technologies like generative AI, especially as the tools, the barriers to entry are getting lower and lower. Anyone, even Shing-hon's grandma can get onto ChatGPT and engage with it and start playing around with prompts and ask for recipe ideas or song lyrics or whatever it is. I think the more that we embrace that experimentation, the more value we can derive from technologies, because you start to get an intuitive sense of things that when the technology is useful and when it's not. And the second piece, and then I promise I'll stop talking, is that I really encourage development teams to start engaging in critical thinking on both what are we trying to do and why are we trying to do it, but also what are the potential downsides of using this technology. I think there's lots going on in the responsible AI space, and especially with it related to generative AI or large language models. But I think just having everybody do some level of critical thinking, asking those couple of questions, we could see large return on that small time investment.
Thank you, Rachel. John, any closing comments?
Yes, I've really enjoyed the conversation as well. Building on the idea and the comment on experimentation, absolutely agree that experimentation is really a key here to understand the technology, what the opportunities are and the risks are. And I think from a software engineering perspective, how can AI and generative AI be applied to the software engineering lifecycle? I think a key message is that it's not just about the coding activities, it's about the upstream activities as well, which includes the documentation. Think of a software repository on your favorite GitHub or whatever. There's a lot of information there that's not just code, and there can be test cases, there can be documentation, there can be even things beyond that are acquisition policy, etc. The opportunities to apply generative AI to assist the acquirers and software engineers is really pretty profound. We're just touching on the early opportunities, and but also trying to understand and explore the risks as well.
Doug, last but not least, final word.
Sure. So I want to build upon some of the things that Rachel and Jasmine and Matt just talked about with respect to equity and fairness and disuse. I think many of us in the education space, in the governance space, have been concerned about the digital divide for decades, which is basically who has access to the internet and who doesn't. And that's largely becoming addressed, not everywhere, but it's getting better. I think we're about to hit the digital chasm, and that's going to occur with the people who know how to use these tools effectively and those who don't. And what's most interesting about that in my mind is the fact that if you go and take a boot camp, if you're a non-computer scientist and you want to become facile at web development, you can take a 24-week boot camp and learn to do some coding. However, you're still going to be competing with people possibly with decades of experience, so you're probably going to struggle to keep up with them. In contrast, I would say there are very few people on the face of the earth who have more than about 6 to 8 months worth of experience with prompt engineering and using LLMs effectively. And so therefore, if people want to get in on the ground floor, this is a wonderful time to start afresh, because you just have to be interested. You don't even have to be a computer scientist per se, or a programmer or a software engineer, in order to be able to become extremely productive if you're willing to put the time and effort into it. And I think that is going to behoove us as a society, as a culture, to think about ways that we can treat these tools as exoskeletons for your brain to be far more productive and effective than would have been the case before. But the challenge is, to Matt's point, not everybody has quite popped into this perspective yet. And we have a lot of work ahead of us to make it more trustworthy, to make it more ethical, and make it more effective, and get people to use it the way it should be used, as opposed to using it as a crutch or a way to not have to think very hard. So I'm extremely optimistic about the future, but it's going to take everybody pitching in to help educate everybody else to be more facile with the use of this brand new technology.
Panelists, great discussion today. Really thank you for sharing your expertise and spending the last hour and a half with us. I'd like to also thank you all for attending today. We really appreciate you taking the time to be here with us. Upon exiting, please hit the like button below and share the archive if you found value. Also, you can subscribe to the SEI's YouTube channel by clicking on the SEI seal in the lower right corner of the video window. Our next webcast will be October 2nd. And the topic will be cyber supply chain risk management. No silver bullet. Registration information is available on our website now and will be emailed out as well. Any questions from today's event, please send them to info@sei.cmu.edu. Thanks, everyone. Have a great day.